In this example, I will teach you how to use polynomial long division to factor polynomials. Then I'm going to teach you how to use that to solve polynomial equations. Let us read the problem. Demonstrate that the cubic polynomial 6x cubed minus 19x squared plus 17x minus 3 is divisible by the linear polynomial 2x minus 3. Next, use your work to factor this cubic polynomial. And finally, solve the equation obtained by setting that cubic polynomial 6x cubed minus 19x squared plus 7x minus 3. Solve the equation obtained by setting that polynomial equal to 0. Now, what does it mean for one polynomial to be divisible by another polynomial? Two things. So one thing is divisible by another if, when we carry out the long division algorithm, in the end the remainder is 0. So saying that A is divisible by B, that is the same thing as saying, well, the remainder is 0. The remainder of what? Remainder of the polynomial division. The remainder of the polynomial division algorithm. Of course, saying that A is divisible by B means that the remainder is 0 not only for polynomial division, it also means the same thing when talking about integer division. So A is divisible by B if the remainder of if A and B are both numbers, then A is divisible by B if the remainder of the integer division algorithm is 0. Okay. So we need to carry out a polynomial long division. Okay. So our dividend is 6x cubed minus 19x squared plus 17x minus 3, and our divisor is 2x minus 3. Okay, we identify the highest order term of the dividend, that is 6x cubed. We identify the highest order term of the divisor, 2x, and we divide one by the other. And we get, I'm sure you guessed it correctly, 3x squared. Next, identify the highest order term. Next, multiply 3x squared by 2x minus 3. And we get 6x cubed minus 9x squared. I'm sure you guessed it correctly. Next, subtract 6x cubed minus 9x squared from the dividend. So subtract the two polynomials that you see highlighted, and you get, I'm sure you guessed it correctly, minus 19x squared minus 9x squared equals negative 10x squared. So we get negative 10x squared plus 17x minus 3. Once again, minus 9x squared equals plus 9x squared. So in fact we are having minus 19x squared minus 9x squared, and that is minus 10x squared, what we wrote there. Okay. Next, we got our intermediate dividend, minus 10x squared plus 17x minus 3. We identified the highest order term in the intermediate dividend, that is minus 10x squared, and we divide it by the highest order term in the divisor. Minus 10x squared divided by 2x equals, I'm sure you guessed it correctly, negative 5x. Next, multiply negative 5x by 2x minus 3. The result is, I'm sure you guessed it correctly, minus 10x squared plus 15x. So once again, why do we get plus 15x? Because minus 5x times minus 3 equals minus times minus is plus, so that equals plus 15x. Okay, now let us subtract minus 10x squared plus 15x from the intermediate dividend, and we get, I'm sure you guessed it correctly, 2x minus 3. Again, we identify the highest order term, that is 2x, divided by the highest order term in the divisor, 2x, to get, I'm sure you guessed it correctly, 1. Finally, we multiply 1 by 2x minus 3 to get 2x minus 3. We subtract the two polynomials to get 0. 0 is of degree smaller than the degree of the divisor, so our division terminates here. Just a reminder, this here is the quotient of our polynomial long division, and this here is the remainder. So this is the remainder of our polynomial division. As promised, the remainder of our polynomial long division is 0. How was that promised? Well, we were promised that the dividend is divisible by 2x minus 3, which, as we said, means that we were promised that the remainder is 0. Okay. So now, let's see how that polynomial long division helps us factor the cubic. As we remember, the interpretation of the polynomial long division was the following. The dividend equals the quotient, so that is the quotient here, right? So this is the quotient here. So the dividend equals the quotient 3x squared minus 5x plus 1 times the divisor 2x minus 3 plus the remainder. But the remainder happens to be 0. So the dividend is the quotient times the divisor plus the remainder 0. But we were lucky and the remainder was 0. So 0 can be omitted. So we were lucky and we got no remainder. So because of that, we have in fact achieved a factorization of our cubic. Right? We have managed to represent our dividend as the product of the quotient and the divisor. Once again, that happens only by the luck of the remainder being 0. So we have in fact factored out our dividend as 3x squared minus 5x plus 1 times 2x minus 3. So we have managed to factor our cubic. Now, our work is not complete. We're done with the polynomial long division, but we have not yet fully factored the cubic. So let's do that. Let's fully factor the cubic. What remains to fully factor the cubic? Well, we need to factor the quadratic 3x squared minus 5x plus 1. We need to factor that expression here. Now, this is a quadratic and we know everything about quadratic factorization. This quadratic doesn't have any easy roots. You can try yourself the divisors of 1 and you'll find out that they don't really work. So since there is no easy factorization of that quadratic, 3x squared minus 5x plus 1, we are going to use the quadratic formula. So the two roots are, well, two roots of a quadratic equation are given by the formula minus b plus or minus radical of b squared minus 4ac over 2a. So the number a equals 3. Number a equals 3. The number b equals negative 5. So the number b equals negative 5. And the number c equals 1. So we got our roots. Let's see how that simplifies. Here we get negative 5, that is 5, plus or minus radical of 25 minus 4 times 3 is 12, the whole thing over 6. So we get 5 plus or minus radical of 13 over 6. 5 plus or minus radical of 13 over 6. So our two roots are 5 plus radical of 13 over 6 and 5 minus radical of 13 over 6. Say this is the root x1 and this is the root x2. So our factorization is complete. We factored our quadratic 3x squared minus 5x plus 1 into a product of two linear terms, x minus x1 and x minus x2. Now our cubic is fully factored into linear terms, and we are done with the factorization. So we have fully factored our cubic. We're almost done with the problem. We have one more thing to do. We need to solve the equation obtained by setting the polynomial we just factored equal to 0. Okay, so 6x cubed minus 19x squared plus 17x minus 3 equals 0. Now we already have a factorization, so let's use it. We get that 3 times x minus 5 plus radical of 13 over 6, double close parenthesis, times open parenthesis x minus open parenthesis 5 minus radical of 13 over 6, double close parenthesis, times 2x minus 3 equals 0. Okay, now that means we're having a product of three numbers that is 0. That means that one of those three numbers must be 0 or more, but of course they can't all simultaneously be 0 because they're different numbers. So that means that either 2x minus 3 is 0, or x minus 5 plus radical of 13 over 6 is 0, which means that x is equal to 5 plus radical of 13 over 6, or x minus 5 minus radical of 13 over 6 is 0, which means that x is equal to 5 minus radical of 13 over 6. We're almost done. We only need to solve this equation. 2x minus 3 equals 0. That is very easy to solve. That's a linear equation. And we see that x equals 3 over 2. So our solution